Hi, this is our last video for 3.6, and this is going to be on slant asymptotes or oblique asymptotes. This particular example has a slant in it. I will talk about the oblique asymptote as we're working. And so we're going to be graphing this guy. And again, the first step we're going to do is our factoring. And if I factor the numerator, it's going to give me an x minus 5 and an x plus 1. All right, so there is my curve. All right, so there's my axes, my x and y axes. We're going to graph this one. So I'm going to walk through our steps again. And the first thing we did is we factored. Our next step would be to reduce it if there was any by taking out a common factor. All that introduces is a hole into your graph. And so forth. So if this had an extra x minus 2 in there, it would take that out. To find the value of that hole is put 2 into what's remaining, and that will tell you where the hole, the y value is for that hole. But we are going to now find our x-intercepts. So do that one first. So our x-intercepts are where the numerator is equal to 0. Maybe I need some more lines in here. Make them smaller. There we go. So when x is 5, 1, 2, 3, 4, 5, and negative 1. So those are the x-intercepts. Our y-intercept is when x is equal to 0, and that's easier to do in the unfactored form, because that would give me a negative 5 over negative 3, or simply 5/3. Which is like 1 2/3. So it's more than 1 but less than 2. Vertical asymptotes are where the denominator is 0. So when x is 3, okay, and just to remind you, we're getting that by taking x minus 3 equal to 0. So x is equal to 3, in case you had forgotten that. All right, we've done intercepts, vertical asymptote. Now we look for horizontal asymptotes. So we look at the degree of the numerator and the degree of the denominator. The degree of the numerator is 2, and the degree of the denominator is 1. So that tells me that we have some sort of other type of asymptote. We won't have a horizontal straight line, but we can have something else. And to find it, what we're going to do is long division. So we're going to take that x squared minus 4x minus 5, and we're going to actually divide it by x minus 3. And so to make x into x squared, we need an x there. So that gives me x squared minus 3x. And now we're going to subtract, which changes our sign, and then I add. And then I need a minus 1, which gives me a negative x plus 3. So we subtract. Okay, which means that this function is actually x minus 1 plus that negative 8 over x minus 3. Now, looking at just the remainder part, as x gets really, really large, either positive infinity or negative infinity, this piece is going to go to 8 over some really, really big number, which is going to be really, really small, or basically 0. Or if you think about the degree of the numerator is 0, the degree of the denominator is 1, so the degree is less than it. So the asymptote here is nothing. So 0, that y equals 0 piece. So we're basically adding 0 on when we get really large. So the asymptote on the ends, what happens as we go in either direction, means that we basically are going to behave like x minus 1. So this is going to be our slant asymptote. If this turns out to be a straight line, so which it is, a linear function, so just an x value here, we have a slant asymptote. If you had done that long division and gotten like x squared or x cubed, we call those oblique asymptotes because it's a curve, but we could still have like it behaving like x squared. So then you'd have this kind of x squared piece going on out there. So now what we're going to do is graph this function with a dotted line. So this is a straight line, slope of 1, y-intercept at -1. So here's -1. And I'm going to put in a dotted line here. So instead of on the ends going towards a horizontal, we're going to be going towards this slant. And now we can throw in some more points here. Yes, I can use the multiplicity idea as well on these values and the asymptote, but I can also put in a few more points. So here I'm just going to substitute in -2, and we can do it either here or here. It really does not matter. So I'm just going to go here. That would be a -7 times a -1 over -5, so -7/5. -7/5 is down here somewhere. So from this point, we're going to go down to this guy, and then we got to get close to that asymptote. And that would have made sense because I knew I couldn't have gone up and then come down because that would have given me another 0, which would have shown up in the numerator. Now from here, I'm going to go and hit my 0. I could put in 1. If I substitute 1 in there, that gives me a -4 times 2 over -2, which is -8 over -2, which is 4. 1, 2, 3, 4. And we have this asymptote here, so we know that it's going to come up. This asymptote is a linear, multiplicity 1, so it's going to come down here, from down here. I'm also going to verify that by putting in 1, 2, 3, 4. So if I substitute 4 in here, so I'll do it over here again. So that's going to give me a -1 times 5 over 1. So that gives me a -5. So here, and I got to come up and hit the 0. This 0 is of multiplicity 1, so it's going to cross through like a straight line. But I could double check and get another point at 6. Wait, 1, 2, 3, 4, 5, 6. Sure. So substituting 6 in here, I get 1 times 7 all over 3, which is 7/3 or 2 and something. 2 and something. And it would come up towards that piece there. And it's probably a lot smoother than I have it looking. It probably looks more like that and this without this extra bumps in there. But we are just looking for rough sketches because we're kind of diving through all the values. I'm going to be looking for all the little pieces. When I'm testing you on this, I will actually ask you for the pieces. I will say factor this. So I'd be looking for you to give me that piece there. I'd ask you for what are the zeros of, or the x-intercepts, what's the y-intercept, where are the asymptotes. Notice this asymptote, if you needed a formula, it's a vertical line, so it would look like x equaling 3. I might ask for the equation of the slant asymptote, which is this guy right here, y equals x minus 1. So I could ask you for pieces. I'm also going to be then asking you to put it all together in a complete graph as well. So that's kind of how I walk you through this section, or this test anyway. I kind of walk you through it a little bit. But this kind of concludes 3.6. There is a lot of material here, but I do have 2 days kind of designated for it. So hopefully that is enough.